Hello, everyone. So I'm going to talk about, so I guess now it's 10 plus years of building open source standards. And I'm going to start from the birth of Parquet and how this all got started. And I'll discuss a bit how we went from Parquet to Arrow, put a quarter in the jar again. That's my pen a couple of times. And I'll finish with Open Lineage, which is the latest open source standards I've been working on. So first, if we get back 15 years ago, I was at Yahoo at the time, and that was the time where Hadoop was getting started. So Yahoo was the company that was funding into Hadoop and developing this area. And I was building platform on top of it, and we were using Pig, if you remember Apache Pig, as a better MapReduce at the time. Before we were stringing together MapReduce jobs with XML workflows. That was not super fun, and Pig seemed like a much better abstractions to do it. Nowadays, Spark kind of took over all the use cases we used Pig for. And that's the project where I got my first committership on an Apache project, and I kept contributing. And over the years, I went from committer to PMC member to PMC chair for a year. So learning all the ropes of the Apache Foundation. It's also around the time the Dremel paper came out, and I read this at the time. So through this Pig community, I got my next job joining Twitter on the data platform team. And at Twitter, there was Hadoop, and so where you can store a lot of data, and querying was all based on MapReduce at the time. So it was very high latency, but cheap. You would launch a job, and then we would go get coffee and wait for the answer. On the other end, we had Vertica. I think, yeah. Hey, Andrew, over there, which Vertica was great, like much lower latency. I'll start with the good side of things. Sorry, but it was great, much lower latency. However, it didn't scale as much as Hadoop, and it was much more expensive, right? So there was always a chicken and egg problem of not being able to put all the data. We didn't have all the tables, and for the tables we had in there, we didn't have all the history, right? We may have a year on the Hadoop cluster and a couple of months in the Vertica cluster. So we couldn't, there was always like, we couldn't put all the data in the Vertica cluster. And there was always this chicken and egg thing. So, and at the same time, around the same time, Michael Stonebreaker, who was the creator of Vertica, was saying like, oh, MapReduce, a major step backwards, right? Like, haven't we done a lot of research on databases over the years? What are you doing this to yourself, like storing files and doing MapReduce on top of it? And so the idea was, well, can we make Hadoop more like Vertica, right? And it's kind of, okay, Hadoop at the basic starting abstraction, we need to add more to it. And so Hadoop is MapReduce on file system, and Vertica is this distributed query engine on top of a columnar storage. And so that's where we started thinking more about this. So the other nice thing that Twitter had is this paper reading group. So we would get together like once a month or so and share about research papers we had read and that were interesting. So read the C-Store paper, the Vertica 7 years later that Andrew authored. Thank you, Andrew. So the Dremel paper, MonetDB paper is also a seminal paper in vectorization. And then thinking about, hey, there's something there. Maybe we can do something. Thinking about columnar layout, right? So if you think of your two-dimensional database, a table, right? You have rows and you have columns, and in your mind, it's two-dimensional. But when you store it on disk, it's a linear, list of bits. So you need to pick which way you write those things. So the typical row layout, you put one row after the other, and you interleave data of different types, right? There might be integers followed by varchar, followed by integers. And so there's things of different types, and it's less efficient to store and to retrieve when you mostly access a subset of the columns, right? When you do SQL, you would select a subset of the columns. And so when you scan the data and it's interleaving the value, you have to scan everything, even if you do a bunch of small skips. In a column layout, well, you just follow the table the other way. You write one column after the other, and you encode them together. So first, this compresses better, and you can make it smaller on disk because you put together all the data of the same types. So you can have encodings that are more efficient. You can compress better. And then when you retrieve a subset of the columns, well, you can easily scan only the parts that you care about, right? And you have big skips instead of a bunch of small ones. It's a lot more efficient. And so that led to creating, at the time, called Red Elm. So Red Elm is an anagram for Dremel. And at Twitter, we had a tendency to name everything after birds. There was no anagram of birds that would make Dremel. So I pick a tree, and birds live in trees, so it works. And Red Elm lived at the intersection of the Dremel paper. Some of the existing file formats, relevant columnar file format, existed in the ecosystem. And following the schema model we depended on at Twitter, which was Thrift and the pig schema model. And so, yeah, it's an anagram. I was kind of ambitious, kind of thinking, oh, we'll rebuild the entire Dremel system. But at the same time, I didn't want to do this myself on my own because that was way too much work. And so I started looking for partners in the community, right? So when you work at Twitter, everybody's on Twitter, everybody's shared, or at least back in the day. So I started looking for people to work with, and that's how I connected to the Impala team at Cloudera, who was also prototyping a columnar format with the same ideas, right? And so we joined forces. We put together the design of what they had been working on the Impala side, what I had been working on, and that became Parquet. And so the big benefits is I was coming from all the Java ecosystem integration, working in this Hadoop ecosystem, which was mostly based on the JVM, integrating with Pig, with Thrift, with Hive later, and so on. And them actually building a distributed query engine on top of it and putting all of those use cases and making sure the format was working well for those use cases. So there was a great collaboration. And that led to the creation of the Parquet project. So if we look quickly, the first commit was somewhere in 2012. Early 2013, we did the announcement of working together on this. Criteo, which is an ad targeting company in France, added Hive support. Apache Drill, which is another SQL on Hadoop project, adopted Parquet for their storage. Netflix was a big contributor, adopting Parquet and adding support for Presto. And then, around that time, Parquet entered the incubator, eventually graduated a year later, and Spark SQL was built on top of Parquet. So along the way, we learned some lessons, right? So there's a thing, creating Parquet, you see this growth in the community, in the adoption and so on, but there's a lot of work that goes into it, right? There's, in a similar way than when I joined the Pig community, then the community has been very welcoming and they kind of pull me in as a committer and then as a PMC member and then keep helping growing the project. You do the same thing, right? Every contributor becomes a stakeholder. They own a piece of the project, and their voice matters. And you want to make this successful by building this collective ownership. So there's not just contributing to your project. By contributing, they become a stakeholder, and that's really important. And there's really a snowball effect, right? If you think at the beginning, was just two companies working together, right? And then slowly others showed interest and they say, oh, we could contribute this, or we could do that. And if I think about Netflix, they tried Parquet. It didn't work very well because they were the first one to use it with S3. And when you do a seek on HDFS, because it's a smart client and you're already at the right point, it does nothing. But when you use it on top of S3, every time you call a seek in the file system API, it's going to do a new HTTP request to the web service. And so that made it really slow on top of S3 for no good reason. So I just spent an afternoon reorganizing the code so it would not do no-op seek that were not needed. And then it became fast for Netflix as well. And then they started contributing to it, made the integration with Presto, and that they became one of the major contributors in the Parquet community. So there's really a lot you can do by helping a little and really bringing people in and making their voice matter, and then they become part of ownership to reach to that snowball effect where, nowadays if I want to stop Parquet, I cannot. Right? I cannot say, you stop the project. And it's interesting to think about the constraints and the benefits of being in an open source foundation. So when you think about open source, there's a lot of different opinions on what that means, right? So the most basic definition of open source is you can read the code. The code is available. However, just this doesn't give you any kind of right of using the code, right? It's not because you can read the code you have the right to use it. That's where licenses are for, right? So the first level of open source licenses, you have typically two big categories. You have the very permissive ones, like the Apache v2 license, where you can do whatever you want with it, with the restriction that there's no guarantees of any kind, right? You cannot sue the author. And the only thing you cannot do is use it without and claiming you did it, right? You cannot have to give credit for you using the code from this project and so on. Then there are more restrictive ones like GPL, which if you're building on top of that open source project, then your license needs also to be GPL. You also need to redistribute. So you cannot build proprietary software on top of it without redistributing it in open source. Second is governance. Often you can see open source projects that are open source. You have open source licenses like the Apache license, but the governance is not open, right? The project is owned by one company and their employees are the contributors, and there's no process for external people to get access to, right? Typically, and that's not how it is all the time, right? It depends a bit how the owner of the project defines it. But it's really important to understand what the governance of the project is, and have this notion, who owns the project? As a contributor, will you eventually become a stakeholder, like we did for Parquet, or are you just a contributor? Like you give the code, but that's it. That's where your rights end. And the last part is having foundations. So things like the Apache Foundation is one. The other big open source foundation is the Linux Foundation that I'll talk more about later. And they both serve similar purposes. You end up with the project and the brand attached to it, owned by the foundation. So there's a guarantee that when a project is in a foundation, the license cannot change. You've seen stories on other projects that were owned by companies. At some point, they can decide of changing the license, which always means, old code is still on the same license, but new code, maybe you have new restrictions on top of it, right? Maybe you cannot build a project, a commercial product on top of it anymore. And so that's where a foundation, putting a project in a foundation is a guarantee that the license is never going to change. The foundation will probably come with requirements on governance, official governance, code of conduct, security, processes to report issues, and so on. And so that's the last important part. So the second chapter goes from Parquet to Arrow. So what was happening in this Parquet community? So in particular, I think if I remember Marcel Kornacker, who was the architect for Impala, mentioning that we needed to build a similar in-memory columnar format to enable vectorization. And at the time, since I had helped the Apache Drill project to adopt Parquet, I knew that the Apache Drill project had a columnar in-memory representation for enabling vectorization of the execution. That all came from the vectorization research. In particular, there's this MonadDB X100 paper that talks about how you can make execution much faster on a modern processor by having a columnar representation and writing your plan in a specific way. And so in particular, this is all based on the fact that modern processors, they don't execute instructions one after another anymore. they do stagger instruction. There's a pipeline, and so the next instruction starts before the previous one is finished. And so that enables the processor to go on a faster clock speed. So overall, the latency of an instruction is the same, right? But since they're staggered and you can go on a faster clock speed, overall, the processor is going faster. But of course, there's one particular flaw that this works only if the next instruction doesn't depend on the previous one, right? Otherwise, you have to wait for the length of the pipeline. And so the whole idea of vectorization is to enable doing independent instruction like this to go at the maximum speed of the processor and remove all the data-dependent branching in the code that would force the processor to wait. And there's a similar notion with the processor cache and memory access, which creates similar latencies in the execution. So we learned something. So when building Parquet, we kind of stumbled on how you grow the community, how you do this. But for building Arrow, we already had the Parquet community, right? We already had a bunch of people together. So we were able to kick off with a consensus on initial requirements and really start with a bigger community, right? Parquet started with just 2 companies, and Arrow started with a much bigger set of contributors and people who wanted it to be successful. And so, you'll notice this timeline starts around the same time the other timeline was finishing. So there was like a first discussion in the Parquet community for needing this in-memory format. We did a kickoff on requirements. We established Arrow as a top-level project right away because, if in the Apache Foundation you're familiar with the incubator project, the incubator is a special purpose project for creating new projects. But actually in the Apache Foundation, you can incubate a project in any existing project. And since the columnar representation already lived in the Apache Drill project for a few years, we just spun it off as already incubating there as directly to a top-level project. And then we started the C++ implementation. Wes McKinney was here, did a lot of the work. Thank you, Wes. I think Wes wanted also to make Arrow as the basis for Pandas 2.0, and that became a reality. There was lots of interest in the GPU community. There was this Go AI initiative like GPU Open Analytics, and the idea was to be able to share data in between different implementation in the GPU. Because one thing that was very inefficient was getting data in and out of the GPU memory to exchange between different pieces of software. So having an in-memory columnar representation that was standardized was a big win for facilitating data exchange between the two. So that led to, like more recently, NVIDIA's this Rapids project that is building GPU-optimized data frames on top of the GPU in open source. That is came out of this initiative. And then Arrow started being integrated in Spark, in particular to speed up Python UDFs interaction. Instead of going through Pickle serialization that was very slow to use Python UDF, instead they could directly use Arrow as an exchange format. And since Pandas was being built on top of Arrow, and everything was a lot faster. And nowadays, just like Parquet, Arrow is supported in major warehouses, and there are a bunch of open source projects that have started using it to speed up things and exchange. Right? If you've seen Data Fusion is one, vectorized engine in open source built on top of it. Andrew, again, spoke about it earlier today. Speaking about it later today, and so on. Oh yeah, and one thing that was that is very hot, and in particular was very hot last year, there's DuckDB, right? So if you think of 15 years ago, the big thing was distributing SQL on top of a bunch of cheap machines. Now the machines have evolved a lot. So now you have like machines with lots of cores, lots of memory, and maybe they have SSDs and so on. So the architecture of the machines have changed a lot. So more recently, you see the development of those databases that are actually optimized to run on a single machine, but very parallel machine, right? So the ratios of accessing data versus accessing memory versus scanning, all those are different, and they get optimized in a much different way. It's interesting to go, I think 30 years ago you had, big appliances parallel, and then we went to distributed, and then we're going back to kind of very parallel appliances that do data very fast. So it's interesting to see that. So a few lessons learned on this part as well, right? I talked about the snowball effect. So for Parquet, we kind of figured it out along the way. And for Arrow, we kind of more said, oh, we need to start with the snowball as big as possible at the beginning with this bootstrapping the community. And if you think of an exponential curve, at the beginning, it looks very flat, right? When you're starting a project, it looks very flat. So you want to be as close to the inflection point as possible so that the things take off. And I think like nowadays you hear about Arrow quite a bit because we reach this level of adoption when it reaches maximum impact and it unlocks a lot of capabilities in enabling this composable query engine that's really powerful in building many different things. And I think, when you think about the task of making people adopt something, right? You're creating an open source standard. How do you achieve this? Like for it to achieve its maximum impact, you need every project to have adopted it. So it looks like it's like boiling the ocean. There's no way we can do this. But actually, you don't need to convince everyone, right? You need to start with focusing on the visionaries who know this is going to work, right? So there's always a whole bunch of people who are waiting to see if it's going to be successful before they invest anything in the project. And that's fine. And then there are a few people who actually see that because they invest in the project, then it's going to be successful, right? So if Wes is one of those people. And you can focus on that small group, right? As an open source community, we can have a small group of people who believe in the vision. They understand that because they put their weight behind the project, then it's going to be successful. And then they convince the early adopters, and then you create like more interest in the project. And because there's more early adopters adopting it, then that's how we get the mainstream. And all the people who are like, well, when I know this is the next standard, then I'll adopt it. Then, when you reach those people, then suddenly everybody's supporting it, right? And it's kind of very, it's not boiling the ocean because there's really a network effect when everything grows really fast. And I think as part of this, someone told me once, oh, you're doing open source the right way, right? When I talked about bringing people in and they own a piece of the project and we build this together. But it's kind of some way I'm cheating, right? Because there was a bit of the underlying point was, oh, you're doing this the hard way, right? Like because you have to support people and there's all this difficult work. And it is hard work to bring everybody together. But I actually enjoy very much working with those people in open source, right? And you build a relationship. And it's a group of people who probably not all work in the same company anyway, right? They're kind of doing different things. And it's an excellent opportunity to work with amazing people and build great relationships along the way and do this together. So it's not about the destination, right? It's about the journey and what you manage to do along the way. So more recently, I've been focusing on open lineage, and it's again thinking about, there's this missing element, this missing standard on how we solve this particular problem around data, right? So if you think of Parquet, it's like a standard for storage. Arrow is a standard for in-memory and exchange between those computation layers. And when you think about those data ecosystems, there's lots of dependencies, right? As long as you're inside your team, people usually understand local best practices, how they depend on each other, how they read data, how they write data, how they collect this. Across teams, that's where friction starts, right? Like that's where people consume data and they don't know where it's coming from and how it's updated, who's updating it, or they produce data and they don't know who consumes it and for what purpose. And sometimes there are surprises, right? You might have built a data set as an experiment and then suddenly someone used it for the model training for the ads targeting, very crucial job that the company relies on, and it's not maintained, right? Like suddenly that's a responsibility you didn't sign up for, and you end up having to maintain it because there was this unknown dependency. And so I've kind of repurposed this Maslow's hierarchy of needs to talk about this. Maslow has this hierarchy of needs when you think about, before you can think about reaching happiness, you need food, you need shelter, you have some basic needs. And once you solve those problems, then you can think of, oh, am I happy? How do I improve myself? How do I reach self-realization and so on? And so in this data hierarchy of needs, there's a similar need. Like we spend most of our time making sure data is available and works and it's clean. And so does data show up? Does it show up in time? Is it correct? And we spend most of our time there, and until we fix this, we can't focus on like business optimization of finding new opportunities and making things work. And so in some ways, we need to get our head above water to make it work. And so that's the reason, so a few years later, I was working at WeWork and being the architect for the data platform. And to me, that was the missing piece in the ecosystem. How do we understand dependencies between the teams, right? How every piece of data, how is it produced, who's writing where, who's reading where, and building this map of all the dependencies between all the jobs and data sets, and who owns what, and how it gets updated. So we created Parquet, which is an open source project that collects all the runs of all the jobs and knows about all the data set and builds the lineage graph and versions everything as it changes, right? So you can understand really what's happening. And when WeWork famously IPO'd or not, we were all available at the same time to do something different. So we might as well start a company and push that vision, right? And the idea was, in the service world, it's very mature. People have SLAs, they have best practices, they think about tracing, they think about on-call. There are a lot of practices in place. In the data world, and I think, let me know if you disagree, but this is the Wild West, right? It's kind of the Stone Age. We have no tooling. Like there's kind of a lot of new tooling, but 5, 7 years ago, we didn't have nothing, right? It was all, when everything works, it works, but as soon as something's broken, it takes days, if not weeks, to figure out what's going on, right? Like you don't know who's producing this data, you don't know how often, you don't know anything. So that led us to, through the creation of Parquet and thinking about what's the most valuable part of this is the creation of open lineage, right? The Parquet is one system that stores all this information, but the key problem that everybody has is getting observability into all those data transformation systems and knowing what's happening, right? So we created open lineage as a way to standardize how we represent lineage across everything. And the only way I know to solve those boiling the ocean problem is through open source, right? Is the only way we're going to tackle this as an industry, and fixing that problem of everything's opaque is through building a standard and everybody chipping in and providing lineage in a standard way, right? So I put some examples. I should update these slides. You could put Atlan and Manta and a few others. Google is on this line now, and Microsoft Purview as well, in consumers of open lineage. And you create this standard, and now suddenly boiling the ocean is not boiling the ocean anymore, right? Because everybody can participate in this ecosystem and benefit from it equally. And so you end up with this slightly different architecture where you put this open lineage representation in the middle, and now it's easier for everyone to consume it, right? Whether you might be interested to consume it as HTTP events or as pushing them into Kafka and doing other things and making the problem much simpler. And so again, so the timeline starts after the end of the previous one. So Parquet joined the LFAI and Data, which is a sub-foundation of the Linux Foundation, so kind of an equivalent to Apache in the Linux Foundation world. end of 2019. We took a page out of the Arrow playbook and thinking about how we build this ecosystem. What's the most valuable part of Marquez? What is the part that the ecosystem needs? We kickstarted the Open Lineage spec in 2020 and growing this community along the way and building support in open source projects, enabling adoption by Microsoft, by Egeria, by Manta, by Atlan. Did a few others integration here that I'm not mentioning everything. Eventually graduating and getting more adoptions along the way. And today, if you check the Open Lineage ecosystem page, you see there's a lot of more of integration and contributor in the community. And the way the Open Lineage model works is you have a very simple core model that is just this notion of recurring job, and there will be runs of those jobs. And for each of those runs, we know what data sets are being read and being written to. Right? So that's a core model. That's the simplest expression of lineage you can think of by modeling really the transformations that are happening. And then for each of those entities, runs, jobs, data set, you add the notion of facets. Right? That's where you add pieces of metadata. On a job, it could be the git SHA of that version of the job that has run. On the data set, it might be a table schema, right? Data set could be a table in a warehouse. It could be a topic in a Kafka broker, and they will have different metadata. So facets are ways to define specific pieces of metadata depending on the specific type of data sets or job, right? You might have column level lineage as a facet. You might have data quality metrics, how many distinct values in this column, how many nulls, these kind of things. And you can have various types of facet depending on what you're doing and what kind of metadata is available. And so here are some examples. I'll go through this a little faster. And the other thing is you can even build custom facets. When one of the goals is in this model is to enable people to extend the model and do as much as they can without having a bottleneck in the spec and facilitating really growing the adoption and innovation around this with having as little as possible a bottleneck in the community. So I'll skip this is the example on the Python and documentation. If you want to learn more, there's a lot you can read here. And the possibilities are endless, right? The key thing is lineage is used for so many different use cases, right? Some people use it for dependency tracing, root cause identification. Why is my data not showing up? It can be used for compliance, whether with privacy laws or banking regulation. It can be used for general governance, knowing where is this particular report getting its data from. Is it using the right tables or is it using the wrong raw tables that have the spam in it? And a whole bunch of use cases, which creates this really healthy ecosystem, right? Like customers can have like Open Lineage turn on and collect a lot of information, and then they can feed into a bunch of different products. Our open source solution, so Marquez is an open source reference implementation if they like to build their own solution on open source, or like play well and send the events to multiple vendors. And they might have a vendor that focuses on compliance, and they may have a vendor that focuses on data observability, data reliability. And those all play well together. And so we learned a few lessons along the way. You know, recently I was explaining how, for Open Lineage, I took a page from Apache Arrow, and that's how we are going to grow the community, and it's going to be great, and so on. And like, very fair question was, what makes you think you can do it again? And it's fair. I mean, like, for the first project, I got lucky and things happened. And I was like, hey, I was at the right time, in the right place. But actually, I thought about it, which just like, it's not like I build a project and then I use mind tricks to convince everyone to use it. It's more like the project focuses on one thing that everybody needs, right? Like, in all these cases, like if you think about this lineage problem, it's just nobody was solving it, right? You need someone to bootstrap this effort in this ecosystem, and then you can start building that flywheel and build momentum and get everybody to adopt. And there's very healthy ecosystem that the more people adopt and become part of it, the more the ecosystem is attractive, right? So there's really like a momentum building. It's like this snowball effect. It's really a good image for it, because the more people join and the community grows, the more it's attractive to others, right? So this kind of a good thing to think about. Oh yeah, and someone was telling me, oh, it's like just like the stone soup story. So the stone soup story, there's this children's book, and someone arrives to a town square in a small city and brings a pot and fills it with water, start heating it and stirring, and puts a stone at the bottom. And people come in, he's like, what are you doing? Well, I'm making a stone soup. And the idea is the stone doesn't bring any flavor. You know, it's like a neutral element. They're just stirring water, right? So it's not really a soup. It's a soup at nothing. But they say, but you can bring your own ingredients to my soup, right? And I'll share the soup with you. And like someone brings leeks, and someone brings carrots, and someone brings something else. And then the more people contribute, the more the soup gets better, and we're sharing it. And so really that's all I'm doing. All I've been doing is stirring the pot and just making a stone soup. And it's because other people come in and add their ingredient, that's why this is so better. And it really built this network effect of, you might say, oh, it's like pushing a rock up a hill, but not really, because, it's like I talk to a few people and they get convinced and they get visionaries, right? And then the magic happens when those other people talk to each other and they talk to other people. And then the community grows exponentially, because every time like someone is convinced, they become themselves like selling the vision. They in turn sell the vision, and the community grows because more people are convinced and they hear from more people, right? And it's just like, all right, now it's a movement. It's not just one guy telling you, hey, we need to build a lineage standard. Like it's really a movement that we're all doing this together because we're convinced we need to build this and make it happen. And so I just finished with, I just wrote down like the lesson learned of, bringing people in and creating this momentum and, just making people stakeholders and keep creating the community. And that magic happens, and you create a movement. So that's it.